Okay, very good morning, my beloved students of underground coal mining methods MN 2102. To this lecture number, I think it is 10, right? Now, before starting the class today, last day of January, I mean 31st, let me share the slide and take your attendance also. Whichever happens first. Right. Let me know whether my slide is visible. Yes, screen is visible now.
Yes, sir.
Very good. And now, my beloved students of underground coal mining methods, welcome to our lecture number 10 on this 31st January 2021. We are discussing in details into module 1 and shortly we'll go into module 2 also. And here, continuing with that, as we have seen from the previous lecture also, what are the factors that are affecting the choice of mining methods? There are so many factors as we were seeing, and this is the way how I also wanted to show one of I take it as a privilege to say he's my teacher, right? Professor Adi Singh Saab, and I was associated with him when he was writing this book. Okay, as a scientist of CSA Simfer at that time, and of course provided a lot of materials for this book. So in this, he has tried to give very good gist of the parameters and try to give some good examples even in the international and our national scenario also as far as coal mining methods are considered. So I hope you must have gone through some of these reference materials. I will also say something about it in a gist so that we can discuss more, interact more in this teaching learning process instead of going through only some text or theory, something like that. So here, when it comes to different parameters, right? Parameters as far as our different choice, which method we should go for as far as underground coal mining methods are concerned. Already I told you in general, our classification also we have seen in the previous special mining methods and then board and pillar long wall in under that different categories already we have seen. I also showed you in details the going through the models what we have board and pillar or long wall, all those things in the previous class itself. I hope that must have given you. And since I am in charge for ground control laboratory, ground control instrumentation laboratory and blasting technology laboratory, those labs also I tried to show to you in the previous classes. With that background, uh, taking you to my department, I mean our department at NIT Rourkela. Now we continue further with when we want to select any method choice, which choice and how these parameters are affecting the choice of the method. We should know a little bit about it. So in that way, even some important points also you can note down. Already I have told you there are very good books written about this by Professor S.P. Mathur Saab, who was a CMD of ECL, CMPDI, and also advisor Ministry Coal, with whom we were working in Southeastern Coalfield and in many projects as a scientist in CMRS, right like that. And then Dr. T.N. Singh, all these books, Underground Winning of Coal and the Professor R.D. Singh and modern methods of mining or extraction of coal like that. So now you will see a different list of parameters, but you should understand how any parameter is affecting in selecting the method. Very simple to understand when it is a thickness of the seam or depth of the working or gradient of the seam. It is very simple. Now, when it comes to your seam, when we are considering different parameters, how to consider? Suppose if the seam thickness is, for example, it may vary even from 0.6 meter and 0.3 meter, even to such a thick seams. I can show you as far as the thickness of the seam is concerned, right? So this is even we have in USSR, that is a former USSR, Ukraine, whatever, even 160 meter thick seams, right? And in India itself, we are having seam. Acha, let me give that question to you, right? Who can say what is the thickest seam in India? Coal seam, since we are talking about the coal mines, and how much of coal reserve that we are having in India, coal resource.
So
Any idea?
131.5 meter.
Right. Yes. First you tell your name and then tell the answer so that that will be information for
So
everybody.
Vishwajit Sahu.
Viswajit, right? Very good. Viswajit. Then what is the maximum thickness of coal seam that we are having in India or in the world?
Sir, 131.5 meter in India.
Very good. Which
It's
place?
in Singrauli mining, I think. Sir,
Very good.
Singrauli.
Right. Very nice. So even they say even up to 160 or like that. 162 meter, 132, whatever. Okay. So that much seems we are having. And how much of reserve is there? Any idea? In India, coal resources, right? Anybody can say, because this is some of the information. You may consider it as a quiz. I may also write as question 1, question 2, quiz 1, quiz 2. This is the way how we have online evaluation every day. Every day while taking class itself, seeing your performance, I have been writing down. Already I told you. For all these, I used to write even this. You see, even in this parameter, what is the latest or whatever it is there. It will be there in that. Okay, don't worry. It is about 300 billion tons. You please note down somewhere around 300 billion. Otherwise, 10 years back, we used to say around 2. And now how it is increasing? That is a question for you at 2:30. I mean, after 30 minutes break, you think about that. Now, in general, when it is coming to the world's thickest, right? It is around 230.73 meter. Somewhere you may note down, because these are some of the informations. Even if while traveling any train, if somebody asks you are a mining engineer and you learned something from underground mining or whatever coal mining, so some people may be interested to chit chat with you. What information you can provide. So in that way it will be useful for you, right? So this was around 230 meters. Okay, in Australia, that is Loyang, Victoria, whatever the names, right? And that is occurring at 21.3 meter depth. That means if it is a surface from 21.3 meter, right, that deposit, that is the thickest in the world. Otherwise, in US or USSR, also or former USSR, they were having in Ural Mountains. That is a place where they have, and that names are something different, right? Like Karkono, something like that. That mines and
The
other names.
Carpathian.
Right, very good. So you must be having that book with you. Very good, nice. So this is in a gist. You should have some idea about the thickness. And now, when it comes to the thin seams, right? So many people have classified these seams in their own style, right? One of the style or one what we follow in India also, I told you, up to 4.8 we consider as a medium, right? And more than 4.8 as a thick seam. Otherwise, in different countries, it is different based on that parameter already I showed you or I told you. In Japan, more than 2.2 meter thickness. And don't be confused with the height of the person and that seam thickness. But unfortunately, it is like that in the climate or whatever it is, right? So in when comes to the thickness or the thin seams, right? Very thin seam is 0.3 to 0.5. Those who are not having the books are somewhere, you can also note down. Thin seams means 0.5 to 1.5. Then medium seam 1.5 to 3.5. Everything I am not writing here. Otherwise this will become a very big material, just a literature, right? And in some countries already I told you more than 3.5 meter also considered as a thick seam. Why I am telling all this? Even some other people, right? So some example, whatever I told just now, classification of thickness is by Ceramic in 1982, because you also should know when classifying the how people have done in different countries. Even I don't want you to remember by name, but when you are working in that area, it is better to understand more and more in details. At least those who are doing assignments related to that aspects, they should know even by name these people have done this type of work, they designed this type of mining methods, and they use this type of methods in this underground coal mining. You should know as far as your area you identified in the reference, you should be aware of it. That's the reason why I am telling you with the reference also. When you are writing, when you are presenting, you also should do that. Right. Then some people used to give roughly less than 1.8 meter as a thin seam, and that also I told you why that clause. And in India also we say around 1.8 meter is that is around 6 feet height, right? Is a normal average person, or the height of the person limited, or in that way average. Okay, and more than that 1.8 to 4.8 as a medium, and all these things are considered in the designing the method. So how it is affecting choice, that I am coming to that, right? And there is a gain and then sing and then different people, they also classified and they considered even 1.5 meter as a thickness for the thin seam like that. So different people, I told you already, right? If somebody in Japan, if they say up to 1.5 also, it doesn't matter. For us 1.5 may be more problem, 1.8 is better. So beyond 1.8, a person can easily enter into that development gallery or anywhere they can work comfortably. So we can call it as a medium or something like that. So this is a way how people try to classify, and in that way, when it is a very thin seam, for example, right? Now it is ruled out that any person with a conventional method, with a pick or with whatever conventional way of loading into the basket and then manual mining, he cannot do it. Very simple to understand. So any conventional method like board and pillar, what we are using with manual, or even with semi-mechanization, with ordinary machines, whatever we are using traditionally, whether it is SDL, LSD, continuous miner, it is very difficult to work in that way, right? Thin seam. There now the people may go, or they went also somewhere, right? Not in India, right? Hydraulic mining, where person need not enter into that, then they can cut with hydraulic pressure. This is the way how people try to have the choice of the methods. And when I said hydraulic mining, of course, not for thin seam, we use for the thick seams, right? And there you please note down somewhere. May not be available in all the books, but in some books, especially by Dr. T.N. Singh and all, with whom we were working in the experimental trial with German collaboration in 1980s, when I was a scientist in CSIR, right? There we did it, that experimental trials, Gopalichek mine in Bharat Coking Coal Limited. That was the first and last hydraulic mining what we used. And there what happened, depending on the interest, we can discuss later. But this is the way how we select. So we cannot go with a conventional board and pillar like that. But longwall mining, people try to use even 0.5 to 1.8, where your galleries, as you have seen, even in the models also, what I explained through some videos also in the previous class, longwall mining, that gate roads, you can make it with keeping your roof as a sandstone or whatever you like, or the floor level as your coal, right? Then you can work with your development of that longwall panel with up to your height of 1.8 or whatever 1.5, or depending on your personalities. Okay, then your working phase can be manless, or even people used to crawl with the pads in the knees, right? So this is a way how you can think of even that type of longwall mining. Even the plows were also used, augers were also used. This is the way how we can think of, right? Where it is something like a manless, or man may be required when there is some problem or some breakdown. Otherwise, it is being cut by a plow or scraper or gathering arm loaders, and then even no support required. Even something happened, person is not there. It is something like a manless at the face, but persons may be there with the development up to your gate roads, up to your height 1.5, 1.8, whatever. This is the way how you can think of a longwall mining, even in that 0.5 to 1.8 meter thick. And beyond, of course, 0.8, no problem, board and pillar or a longwall, whatever. This is the way how we can think of. And even in France, people used even uh, blasting gallery methods, right? Where in a single pass, those methods I will be explaining you later. This is the way how you can think of. And when it comes to the gradient, next point, gradient of the seam, have any doubts? Of course, we will take up at 30. Now it is around 25. Okay. Now thickness after this gradient of the seam. Then their seams can be even flat, right? And while telling this, I am giving you many Indian examples also, and a few from different books, some foreign examples also in between, right? Where I wish you should be aware of with your previous geology, even mining geology, whatever you learned about our Indian conditions first. Okay, so where in southeastern coalfields, almost all the deposits, or many majority, are with 1 in 50 or almost horizontal, right? So that is almost flat. 1 in 50 means like in 50 meters there is 1 meter. That is a dip. 1 in 50. That is the meaning of it. Very simple. That means if it is 1 in 1 means in horizontal 1, vertical 1. So this is 45 degrees. This is a dipping of the seams. So much of deep seams were there. For example, I mean steep seams. We call this steep seam, right? So where we call are in general, there are many people. Again, I am giving you examples of very ancient people also, like somebody in Russia again in 1950s, 58. They are given Shaveko, right? So shaving co, something like that, some name. Okay, where gently dipping, he says 0 to 25 degree. Inclined seam 25 to 45 degree. Then steeply inclined means more than 45 degree. 45 degree anybody can understand. 1 in 1 is 45 degree. Very simple. Tan theta 1, right? Then there are so many other people, right? Fritz Potag, maybe from Germany, right? These people in 1954 itself, they classified and then they tried to give some methods, right? So it's a flat, they consider 0 to 20 degree, right? Semi-steep means 20 to 40, then steep is greater than 40. This is the way how, based on their conditions in their countries. So initially anybody tried to classify based on their country, their position of the reserves, everything. Later, they try to universalize or internationalize those systems, right? That's what. Now you can also classify based on your system in your mines, in your country, in your state, in your coal fields. So many things can be done. All these are all empirical. That is what I tell you, my beloved students of underground coal mining methods, MN 2102. Now, many empirical formulations and all assumption we use it. So this is still an art of mining in designing the method. Of course, we are trying to make it more of a science with more and more data, quantitative data, and then doing a lot of analysis, even applying machine learning and artificial intelligence, so many things. That also I will discuss with you. Now, if it is a seams which are very steep, for example, right? Now it is very simple to understand, you know very well. If I keep a pillar, if I want to use it, that pillar itself is in such a state that pillar itself may slide sometime or it has towards the gravity, right? So suppose if that pillar in that strata, if it is some weak bands that may slide along that band itself. So it is very difficult again when going for a board and pillar when it is very much inclined. Even suppose you can imagine a situation. Suppose you are working somewhere in this place, right? Maybe from this side to this side or this side to this side. At some working places, maybe split galleries may be along the level, slices may be along dip rise or oblique to that in apparent dip direction. There are so many ways we select based on that inclination and all in the method and orientations. Okay, in that now sometimes when there is inclination, even your golf also may get flushed, right? And from the golf also material may come into your face and so many things may happen if it is very inclined. And that is the reason why board and pillar may not be successful in that way. It is better to go for some type of horizontal slicing, right? Something like that. Okay, that may be a very good choice. Then when it is a thin seam and then steep seam. So in that way, the best is now, let me know before that. You also read or reading about metal mining methods also in this semester or previous? Yes, no? Anybody, please? Metal mining methods. Are you learning or it will come later? Because we have been modifying a syllabus, courses selection as a professional elective many times.
So till now it's not specifically written.
Very nice, very good, very good. Don't worry. Yeah, okay, I understood.
Only such
So,
development of mining,
right,
sir,
right.
not
There is a metal mining methods also as a separate, okay, as a maybe a professional elective like that some people may take. But in the metal mining methods also you must have seen a breast stopping. Breaststroking means breaststroke, right? You'll be doing swimming, right? Many people must be knowing swimming. So breaststroke means there will be a gallery. I blast on the sides, and if it is inclined like this, right? Whatever I blast, this material will flow through that gallery to the lower level. That is what is a breaststroking means in the metal mine. In coal mines also it is steep. In that way also we can do. Just blast it, that material will flow on its own to the lower levels. From there you can collect through chute and so many things. Of course, that methods we will go later, but this is a way how we can select and design methods, innovative methods based on the site specific conditions, right? And then there may be, suppose if it is moderately thick, right? And it is almost vertical. Now this type of things, now we can deal with in such a way that suppose if you are having along the strike 1 kilometer, half a kilometer, or even the thickness may vary in a different strike, moderately thick already we said, right? So there ascending order with stowing, this is the way how generally it is followed. And then if it is very steep and also thick, then horizon development we follow, even hydraulic mining we go. And when it is a flat, right, and thick seams also, then you know very well option is open for us, right? You can go for
Excuse me, sir.
Yes, yes,
Sir, this is Devi
right.
Prasad Rana. Yes, sir. Now we have a break for 5 minutes, sir.
Very nice.
This is
So
going to
I will
9:30.
break just within one minute after explaining this context of only gradient issue. Okay, right, within a minute. So that means if it is a flat seam and then even if it is a thick, then now many options are open to you, right? That means now you can even go for board and pillar, long wall, it doesn't matter, right? Again, other conditions you have to look into, right? If it is very thick, then going into multi-level or single pass and so many things already by name, we have seen it, but all that methods also we will go into that. And then there it is very simple for you. You can go for rope haulage, conveyors, transport, and so many things like that. So this is a way how these only two parameters we discussed at present. We will go into other issues also, right? And now I am taking a break. Now let us go into your doubts. If you have any doubts, let me just break it here. Yeah. Any doubts?
Sir,
Yes.
this is
Right.
Ashmir. Sir, I
Taking
have a
attendance.
doubt. I have a doubt
Yeah,
that
please. Right.
about long wall mining. What is the surface condition for long wall mining? Like, what will be the sharp surface?
Very
Like,
good
if it is
question.
the sharp upper surface down, or what we have to do, and if there is forest free place, what we have to do there?
Good, good. So long wall mining, what are the surface conditions, right?
Sir.
Okay. Any other doubts? So I will address all that. That will be better so that if you have any other doubts. Anybody? Acha, if there are no other doubts. So long wall mining already we have seen little bit. Of course, while discussing about the total design, we will be learning more, right? And from the reference and other things also books, you must have been seeing that also. It should be a very good interaction for us when you know more and more. Now, in long wall mining, you have seen that when we are taking any deposit, this face length and panel lengths are even more than 100-meter face length, 200-meter. Even nowadays we are going to 300-meter, 350-meter also in Australia and other places. People are doing that. And even kilometer, 3 kilometers. Otherwise we started with around 500-meter or 1 kilometer like that. Now we are going, even people are going up to 3 kilometers, 2 kilometers. Already we are doing it in our country itself, in Adiala, Janjra, other places. So with that big size of the panels, then when it comes to the surface, what happens is now a surface, now if it is a long wall panel and this is your surface, Now, as our friend asked nicely, a good genuine question. Now, what happens if it is a deep, I mean a board pillar or long wall on the surface? What is happening here is, now let me adjust screening, let it be there. Otherwise it takes some more time. Now, this surface, you will get a uniform subsidence, right? The meaning here is, if it is a long wall, now there will be a lot of cracks only at these places and these places. I mean, along the boundary, I mean, along the boundary of the panel, I mean, a barrier. Above the barrier, little bit on this side, there will be some cracks. Otherwise, there may not be perceptible cracks and all on these. Now you can imagine, even if it is a any forest or something, it is there, right? There will be a lot of damage only on these places, almost no damage, or because it will be uniformly coming down. Even if it is a house, and if a house can come down like this, so there will not be any cracks in the house. Can you imagine that situation? That's what is our harmonic mining is. Harmonic mining. Suppose now you just imagine this is a house, right? This is a surface structure. House is there. That house, let me show you in a bigger size. Okay, your house will be big, you as a mines manager. Now, if this is a house, now when it is subsiding, right? If it is a boarding pillar, here itself there will be so many cracks, right, at different places. Then that cracks lead to tensile and compressive strains at the places, and then you'll get a lot of cracks in the house and everything will collapse, right? Suppose if these cracks and all are happening only along the barriers, right? This is a long wall, right? And then only on the barrier that is happening, and all the house, if it comes down like this, there is no damage to the house at all, right? So there are so many, and that is what is harmonic mining is. Even that damage in different levels of workings we can control, but that is very, very difficult. It is not total science in design, but there are so many limitations and assumptions in the designs, where suppose in one long wall panel it is like this, another long wall panel like this, where compressive strain of this long wall panel here is compensated by tensile strain of another panel, underlying or overlying panel. Then what will happen? All these also, they are not very strain. I mean, compressive and tensile same. Now everything will be, now that will be something like this. All these three panels, there are three panels. Then all these three panels, there will be damage on this side and this side. And in this, there will not be any damage. Everything will settle down, come down. Even if there is a forest, and that also will not be having any cracks at this place, only at this place. Of course, that is a different issue. I hope you understood it, right?
Yes, sir. Yes, sir.
Shall we continue further? Any
Yes,
other
sir.
doubts? I think I asked some more quiz question. Who can answer? I did not write a quiz. But of course, we
Uh,
can write also. Don't
you
worry.
said how it's increasing the coal like that.
Yes. Anybody want to respond?
Sir, as the demand of coal is increasing, so
Right.
the price of coal also increasing. So the cut-off rate of coal may increase. So
Right.
it is in indirectly the coal seam is or coal reserves is increasing. Or with the technology, we can say that coal resources and reserve are or the different things. But previously, we should not economically and safely extract the coal that from reserve. But now is the technology we can extract more coal with advanced technology. So we can say that that aspect we can say that coal reserve is increasing. And
Very good. Any other response? That is very good. Any other response from anybody? Meanwhile, I am just scanning through what we will be showing you later. With the latest technologies also we will show. Anybody else? ठीक है. अभी कौन बताया जी, आपका नाम भी बोलने के लिए बोल रहा था बीच में.
sir, Ayush Meher.
Ayush has given a very good idea. One more thing here is, even I was just trying to scan through meanwhile to give you some latest technologies of continuous miners and all. Now, the increasing means very simple. Here itself, let me write as a question. Okay. So what happens every year? Our process of exploration is a continuous process. Okay, exploration is a continuous process. How this coal resource increased from 2000 to about not 2000, 300 billion tons. Okay. That is over a decade. That was a question. Okay, right. So our point here is, so exploration is a continuous process and we have been doing that. So now we are considering some blocks sometime and some other time, so many other blocks. We are also importing, I mean, we are also inviting foreign agencies to explore even our reserves. You know that? So all this process, so every year there will be more and more reserves. That is very simple to understand. That is not a big question. Okay. Now, continuing further with you understood how to select these methods based on thickness of the seam and also the depth gradient of the seam. Now coming to the depth cover, already I told you that we have been working in the world, in the international scenario, up to about 1.2 kilometers in China and then Utah, US and other places. But in India, we went around 600 maybe. And of course, planning and we will go. When other countries, they can go up to 1 kilometer and beyond. Why not? It is nowadays, it is a global system, right? Globalization, where you can import any technologies and then missionaries, so many things can be done. So coming to this depth, how this is affecting the selection of the methods of underground coal mining. Now, in general, people consider 300-meter as a limit for board and pillar. It is better, don't go beyond that. Of course, we have some mines where it 400 also we are doing with board and pillar and all, but the best or the limit we can take is 300. But based on my limited experience of 35 years, right, in my designs, I say even 250-meter because we face a lot of problems. At 250-meter itself, I can give you the names of the mines, you please note down. And later I can give you its total details about even its geology, mining methods, performance, problems, solutions, investigation, so many things based on your interest. And especially I am sure those who have taken the assignment and trying to prepare in the international journal paper already started, they must have started in those areas. They can get a lot of information from me also. That is the way how I want to encourage you, my underground mining method students of MN2102. Okay. So even Thansi mine, you note down this in WCL, where it is a steel grade coal. We are spending the highest cost of support system we used in that underground mine. Otherwise, it was supposed to be closed. That mine should be closed because of incurring so many losses at that time in 2K, that is 2000, when Mr. Wies was the CMD and Mr. Okay, let us not go to the name. Some DJMS and other teams, we were working on that in redesigning and then doing a lot of things. Where even at 200, 250-meter, under the influence of some hills and valleys and other places, we face a lot of problems, even at 250-meter itself in the board and pillar method, facing guttering and then so many strata control problems and all. So that is the reason why I told you, right? Even 250-meter also can be a limit where we face a lot of problems, even in Bellampalli area, right? Goleti and some other place, mine in Singareni, collieries, we face problem when it is beyond 250 meters, where some guttering, cutter roof failure and all we saw. These are some example I am telling from the books and our experience, and in future, you have to consider and design innovative methods, my beloved students, for India and of course in the world based on your intelligence and knowledge. And then even as I told you, even up to 600 also people have, but they face a lot of problems in board and pillar. And why we are facing problem when we are going with depth? There are so many reasons for that. Okay, some of the reasons, of course, I want from you also. Anybody can respond telling their name. What could be the problem other than whatever I said a little? What could be a problem when you are going in deep into the earth crust? Anybody can respond, please. What are other
So the
problems you
temp
anticipate? Yes, please. Tell your
yes, sir,
name and
this is
then. Ayush,
yes,
yes.
sir.
What other problems?
So yes, sir, this is Aryaman. So the
Okay,
temperature
very good.
increases
Right,
very high. So
right.
working conditions are very poor.
Very good. One is the temperature. Then how much temperature will be there? Anybody want to respond on that? How much is the temperature when you go depth? Anybody? Now, next point. Anybody? Okay, it's okay. That is what is considered as a geothermal gradient. Okay. And in general, in India, for the different countries, it will be different. Suppose if it's a cold country, Canada or some other place, right? Where now the temperature gradient, when you are going deep, obviously that temperature will be more because of so much of lava, and then uh, core in the earth crust itself is under molten stage. Your rocks, you can imagine how many thousands of degrees will be there. Its effect will be there definitely, but it is about any idea, any guess? When you are going in depth, how much increase of temperature will be there? Anybody?
30 degrees Celsius per kilometer.
50 degrees
per mile.
centigrade at
Per mile.
at how much depth?
15 degree Fahrenheit per mile, sir.
50 degree
15 degree Fahrenheit per mile.
15 degree Fahrenheit per
Mile.
mile.
Mile, MILE, mile.
वैसा नहीं बोलते हैं. You should say for 100 meter depth when you go, how much degree can increase? Or 1 kilometer नीचे जाने से how much increase? In NEP 2020, we have to talk in your language also, right?
Yes, sir.
So that is what is a geothermal gradient means. ठीक है, it's all right. You can also see even in the Google में लिखने से भी आ जाएगा. Don't worry for that. Okay, right. So it will be about 1 degree when you are going for about 60 to 100 meter depth. There will be increase of the temperature. Okay, and that will be different in different countries, of course. And there is one example nicely mentioned by Professor Ade Singh already in that book. Also, you may see at around 1524 meters depth, and there is also reference of 1950s, 55. Okay, I don't want to give so many reference, but this style of writing you will learn. That's why I'm giving that. Writing when you are preparing your assignment in the international journal format and then present. So that is the reason why I'm telling you, right? So where there is a Brahmalo, right? Bromlo, somebody in 1955. In British coalfields, when they had 1524 meter depth, right? So high virgin rock temperature, that's what they have mentioned in that, right? Of course, where when there is a temperature, how much temperature you can tolerate? Any idea? Because when you are mining, you are entering into that place unless it is total manless mine. How much temperature? Ultimately, whenever you are designing any method, these all depending on your system, safety, health, conservation, all those things are associated with in designing or choice of the methods, right? How much temperature is comfortable for you? How much temperature is tolerable for you? Any idea?
45 to 50 degree Celsius is tolerable for us.
When it increases,
25 is suitable, sir.
crosses 50 degree, it is very difficult. Even state governments they have the authority to declare close, right? Nobody to come out, right? There are so many things, stipulations. I'm not going into our constitution and Indian mining or Indian law like that, right? That is already there.
Up to 32 degrees.
ठीक है, बढ़िया है. That's what is also mentioned in our regulation 130 of CMR 1957, as already I told you last time. Okay, and of course, so now when we go in depth, we are discussing about the point number 3. When you are going into the depth, now there is a geothermal gradient where the temperature that requires more ventilation to be provided. That is a problem. You cannot provide so much. Otherwise, you please note down somewhere. We have done air conditioning in the mines, air cooling in the mines, and that can be even in polar goldfield or even in, you please note down, VK7 incline mine, Singareni collieries, we have done air cooling, right? In the mines when the temperature is becoming very high, right? Even AC, आप लोग बोलते हैं ना, air condition, right? Is also being done to control this. So this type of problems will come. And of course, there are so many times what happens when you are going at depth, more stresses will be there. When it is a pillar, then pillar will get burst. That's that type of bumps. You can say coal bumps. So many things will happen. Your sides may become very weak. So Bowden pillar is not at all suggested or considered as a choice of that method. And in that case, what method you should prefer then? When there is more depth, to some extent with some stress relieving techniques, and stress relieving also I will give you one of our senior, right? Yesterday he was giving one talk, right? Professor Uma Maheshwar Rao, who was my senior, we studied together for some time in Kottagudem School of Mines, Usmania. He will be joining us shortly as a director in NIT Rourkela, okay? Where he also nicely explained the stress management for the student, right? And then stress relieving, which is more important, right? So as MS counseling and psychotherapy, whatever I did, from that base also I'm telling you, it is not just managing the stress, you should relieve the stress. And that's what the way we design the methods, right? You relieve the stress and stress of even the learning. That's what is required. And especially for underground mining engineers, underground mining methods, we design all that. So I have tried to give you that type of referencing for you, right? So now this is as far as the depth is concerned, my beloved students, and then now the shape of the deposit, right? Now you know very well the shape of the deposit means now you have seen. Who can say something about this? What is the coal deposit shape, how it is? Because you learned, this also will become like a quiz question, my beloved students, for you, right? This, that's number 2 is shapes. Shapes of the deposit, whatever you learned about it. Shapes of the coal deposits. What shapes are there? You have seen in India, geology and so many things. Deposits, especially in India. I'm not talking about the world. At least you should know about in India, coal major formations. What is the shape of the deposits? Who want to respond? Anybody?
So
You like
Mahesh,
yes. Yes.
The
Please.
bedded deposit.
Very good. Any other? What are the shapes of the deposits and how it is affecting our mining methods and all, depending on that. Once you understand that the deposit will be like this, then it is easy for us to understand what type of methods we can use based on different shapes. Okay, don't worry for that. Now coming to this issue of the shape of the deposits, in general, as our friend said rightly, right? In general, these are all sedimentary deposits. Otherwise, that is also there as another theory. In situ theory is also there. Like a pond, also there may be a deposit we have in different other countries and some places. But we are more concerned with the sedimentary deposits and then mining, because majority of the deposits are of sedimentary origin. And when it comes to the shape, when it is a sedimentary means it will be almost flat. And sometimes, right? Sometimes even that deposit might have got folded. This is what I was expecting from you, right? That deposit must have been folded, and that must have been, while deposition itself, something like a basin. It is not a flat, but a basin, where if it is a basin means it will look like this, right? A deposit. This side and something like a anticlinal portion and synclinal portion, right? Like this syncline, and it can be somewhere, it can be anticline portion. It might have been folded like this. Something might have happened, and otherwise if it is a deposit and there must have been, this is a deposit continuity, must have been faulted, and here this is a deposit of 10-20 kilometer here area, 3-4 kilometer down fault, downward, there may be a movement, displacement, and this may be at 200 meter and this must have been displaced by 500 meter more maybe 700 meter, right? There, it will be so many ways it will get affected. That is what is the shape of the deposit I was expecting from you about this, whatever is there. Don't worry for that. So in that case, if it is a regular deposit, no problem, flat. I mean, maybe steeply inclined or inclined, all those things you know very well, right? If it is a regular, there is no folding, something like this, where I cannot use a method at this flat portion and a method at this inclined portion. That will be different methods required. That's what is the meaning. Undulating, right? And in many books also you will see a lot of information, whatever the reference I've been providing, and then as a part of national mission project, already I told you in our along with our IIT Kharagpur, we prepared long back that materials also partly I have already sent to you and will be sharing. Okay. So in some cases undulating, so it will be very difficult. You cannot use same method at every place. But if it is a regular, yes, it is steeply inclined, you go by long walla, but if it is a flat and then you go by board and pillar in that portion, whatever, and hydraulic mining and other things. This is the way how. Okay, there can be something like a pond and all I told you, right? So that example also given in some books you can read, right? Where they go for open cast mining if it is at shallow depths. This is what happens. And there may be seams where I hope I have told you before also. So there is a seam. There's a queen seam, you please note down. That is a 21 incline, Yellandu, Singareni collieries, right? That was the first mine we started in southern India, coal mines in Singareni collieries. That is the reason why Yellandu is a prominent place where, of course, I was working in 1980s, right? As assistant manager and in charge of mission mining districts, coal mines, biggest mines, right? So now what happens? There may be seam. Now suppose this is a seam of 20 meter here, and because of some intrusions and all, so that intrusions may be like this. Okay, there is an intrusion and then this seam is split into two, right? So in that way there are so many seams. We used to have a queen seam of around 10 meter, and below that king seam with around 70 meter parting, and above that we have some split seams of index 2, index 1, index 2 seams of 2-3 meter with 3-4 meter parting, 7 meter parting. This is the way how there may be so many seams, shape and all. That's a split seams may be there, right? And there may be folding and all. Nice example was given by our Singh Saab here, Professor Ade Singh, who was also my teacher. That's the reason why I was showing you, so that whenever you are preparing your assignment in any journal format, you should give not 2013 reference here, your latest 2021 by somebody who designed some methods based on your assignment topic. You should write about them, and like that at least 10 years of references you should write. That gives you that yes, you know about that subject like that. Okay, so and here folding of some very good in the Spain example was given in page number 29. That also I am giving you, my beloved students, in page number 29 of Professor Ade Singh's this book, whatever I am referring, where there was a folds, right? You can see how it was there. I don't know whether you are able to see. Are you able to see this? Yes, no. Yes, no.
Yes, sir.
Right. So that type of folding. Now where this is a deposit that has become like this, right? Aisa ho gaya, right? From around 180 meter depth cover and all started from here, right? If it is outcropping, of course they extract even by open cast some part of it, or incropping, then from there you will drive an incline or shaft, and then horizon mining, because now you cannot have in-seam development, but we can have only place where it is a flat. Otherwise you should have, if the deposit is something like this, then you are having, this is a folded like this and faulted, so many things. Then here you can have a shaft, and it is better to have a shaft here instead of having it on this side. On the upper side or roof side, if you are having a shaft, that will get affected by the workings. It will not get affected if it is there on the, even in metal mining also, your location of the shaft will be on the deep side or on the footwall side or this side on the floor side. So this is the way how we locate, and then horizon mining we connect here and there from in-seam development, and this is the way how they used to do. And that was an example of whatever I have told you, folding in that seam. That is a pastora, some mine name also I have given you, and our Indian examples already I have given you for split seams and other things, where you will be selecting a different methods. In queen seam, we were using even blasting gallery method. We used machine mining, board and pillar, and in index seam and one, and we used even sometimes long back also, even scrapers were also used for collecting and so many things. Whenever there was a folding, we started a centenary incline on 100th year of Singareni collieries when I was working there in 1987. Okay, right. So now I should not take much time, but today it is around now going to be 10. So who is ready to summarize? Then we will close for today. Otherwise, in the next class, as I told you, that is the reason why I used to show you what we will be discussing later in seam development, horizon mining, board and pillar, gallery dimensions, pillar size, width, panel, how much it should be, extraction in the latest some of the projects where we designed, along with our Professor L.P. Rai, Kilar from Computer Science and Electronics Department, their professors and team. We used to do how transdisciplinary research in NEP 2020 multiple. And then continuous miners and then resin bolting, latest technologies. With all this, we will be discussing all these things in the next classes. I think we will cover those things in the next class with the latest design. Now, we will summarize. Just I am going to take your attendance and then close for today. By that time, somebody can summarize.
Hello,
Yes,
sir.
anybody, please.
This is Spatika, and I want to summarize
Very good, excellent. Continue.
Okay, sir. So, as we have discussed in our earlier classes, we got to know that coal seams have varying thickness, depths, and structures, and occur at different depths. Hence, it becomes a prerequisite to make a correct choice of the method of mining for success. The factors which influence the choice of mining methods are um, the thickness of the seam, the gradient of the seam, the depth of the seam, the shape. We discussed about these four factors today. We started with the thickness of the seam. The thickness of the coal seams varies from a few centimeters to like meters to several meters. In India, the thickest seam is in Singrauli, that is around 162 meter, and the world's thickest coal seam is around 230.73 meter, and that is in Australia. Uh, then we went to the gradient of the seam. Coal seams occur at varying gradients from 0 to 90 degree and are generally classified as gently dipping, which is from 0 degree to 25 degree, incline dipping, which is from 25 degree to 45, and steep gradient, which is below 90 degree. Then we learned about the depth of the seam. Then we learned about the depth of the seam, and then we went to the shape of the deposit. Okay, so about the depth of the seam, the limit for broad and pillar type of mining is 250 to 300 meter, depending upon the place. It can also be extended to 600 meter, but we face some problems, such as the temperature increases, and that is 1 degree per 60 to 100 meter depth. And also the wall rocks of the coal fields become weaker. So hence a system of mining which can give better ventilation and roof control will be obvious choice.
Nice.
Okay.
Okay, it's okay. And
Okay.
in the excuse me, in the next class, we'll be seeing all other parameters influencing the choice, and also the latest technologies being used in India, especially for board and pillar, long wall, and other methods also, of course, designing. All those things we will discuss further in the subsequent classes. Okay, then all the best, and then I
Sir,
hope. Yes, madam.
I want.
Pratika, madam.
Sir, my name is Spatika, Spatika.
Good. So whatever I could see here with little size in that, इसलिए मैं इसमें तो KS Patika. It is
Sir,
written like
it's
stick.
K is
KS
Spatika.
Patika. Yeah, that means KS Patika. I mean yours Patika.
K is Spatika. Sir, K is
K
the
is
first
Patika.
name actually. K is
Acha,
Spatika first. Yeah.
Spatika means a crystal. Is it right?
Yeah.
You
Yes,
are
sir.
crystal
Yes.
clear. Right, very good. All the best, Spatika madam. She nicely summarized it. And let us close for today. I think you may be having other classes. We should not enter into others class. I have taken attendance and I am trying to stop recording, but we love each other so that it is not getting stopped. और कुछ समय के लिए रहने के लिए बोलता है.